Hey everybody, welcome back to another video of Bits and Talks with TSHNT, and we are here with another question, maximum sub-array sum. So we'll be given an array of length n consisting of integers, and what is a sub-array? A continuous segment of an array, right? In other words, it can be formed by removing 0 or more integers from the beginning or from the end. And we need to find the sum of the sub-array having maximum sum among all these sub-arrays. So what we can do is, like, what is a subarray basically? If this is 1, 2, 7, 4, minus 4, 3, let us just a second. So yeah. Okay. So question is 1, 2, right. So what is a subarray? Either this portion can be a subarray, or this can be a subarray, this can alone be a subarray, this can be a subarray, this is already encountered, so this, right? So from this we can have infinite subarrays, not infinite but finite, but many subarrays. So 2 to 7, but there is not any case like you can have a subarray from 7 then you have 1. So this is not a case, right? So these are the subarrays. Now we need to find the maximum subarray sum. First approach can be, the very easy approach that we can think of is just find all the subarrays and then find the sum of all these subarrays, and then what you can do is just return the maximum sub. So we can give a solution of O of n cube time complexity first. That will turn out to be, we will run a loop. First for loop will run from int I is equals to 0 to n minus 1, right? Other for loop will run from I to n minus 1, and next for loop will run from I to j. Sorry, yeah, this will run from j, and another for loop k is equals to I. Let k is equals to I to j, and in each for loop we will calculate the sum. Let's say our I is this. Firstly, I and j will initially point to this. Okay, so our sum will be 1. Then our j will point to this. So this sub array is formed, right? So this will be the sum, that is 1 plus 2 is 3. Then I will point this here, 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 here. Then I will j will point here, 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 and then I will also increase. So this way we can get a 3 O of n cube time complexity solution. Other thing we can do is the best linear solution. If you are asked to perform a linear solution, what we can do is we can perform Kadane's or Kadane's algorithm, whatever you pronounce it. Right, so what it says is we can get the maximum subarray sum just linearly traversing the array. What we can do is just initialize two variables, max sum and sum, that will store the current sum of each subarray, and one variable that will store the maximum sum of all these subarrays, maximum sum encountered till now for all the subarrays. Initialize both to zeros till now, right? So what we will do is we will traverse this array 1. Okay, so now sum will get updated to 1. Okay, and the maximum sum will be max of this maximum sum and this sum. So obviously 1 or 0, so max sum will also get updated, right? In the next case, what we will do is 2, so sum will be 3. and our max sum will also get updated to 3, right? So 3 plus 7, this is again 10. Max sum will now get updated to 10, right? Then is minus 4, so this will get to 6. Now our max sum encountered till now is 10, so 10 and 6, so it will not get updated. Then is 3, so this will turn out to be 9, still max, no updation in max sum. Then 2, this will get updated to 11. Now max sum will get updated, right? Then minus 10, so this will get updated to 1, right? And max sum will remain the same, 9, so this will get updated to 10, and then again 1, right? So here our maximum sum obtained is 11, right? Let us once solve in another problem where you will get the solution, like intuition of 10, 20, minus 30, 40, minus 50, 60. So this is 10, 40, minus 50 and 60. So similar approach, sum and again max sum, right? That will store the maximum sum encountered till now. So sum, then 10, then this 20 will turn out to be 30. Maximum sum will also update to 30, right? Minus 30, so this will turn out to be 0. No updation, maximum sum, right? Then 40, then minus 50, so this will turn out to be now negative, right? This is minus 10, this will change to minus 10. What we will do is, when our sum is less than 0, the condition is when our sum is less than 0, just update the value of sum to 0. Why? Let me give you a solution for this. Because we need to encounter the maximum sum of these subarrays. When sum is already negative, we don't want that. We want to maximize this sum, right? So even we have a negative place, like we have a negative place in that particular subarray, we will discard that subarray. So next we will do is 60. So our sum is now 60 and maximum sum is also 60. And that is encountered by this. Okay, this alone subarray, right? Here the break was broken by minus 50, so 60 is the maximum sum, right? Let us now see the code and you will get a better understanding. I hope you've understood the intuition and the whole logic behind this Kadane's algorithm. Okay, so just make two variables, sum and max sum. Just traverse the array, update the sum variable. If it is less than 0, initialize sum to 0, reinitialize sum to 0, and always update the maximum sum and just return the maximum sum obtained till now. So submit this problem and successfully it has passed all the test cases. Still any doubt, just put that out in comments. I will try to solve them. Thank you. Consider subscribing the channel too for more such videos.